I must apologise this morning. I'm channeling Steve Ballmer a little bit. I know it's covered in sweat. These things never get, these launches never get any easier or less exciting on the day, which is probably a good thing. So I thought I'd start by just talking very briefly about the history of Raspberry Pi. I guess a number of you kind of know really where we came from, but I thought I'd just kind of recap because we've come an awful long way in 4 years together. And it's easy, I think, to, with all of the exciting stuff that we do in the maker community and all of the exciting stuff we do in the industrial and embedded community, I think it's very easy to forget like how we came into this, what it is that we're trying to accomplish with Raspberry Pi. So I guess the genesis of Raspberry Pi, we've been selling things that you'll recognise as Raspberry Pis for exactly 4 years today. But the genesis of Raspberry Pi was back in 2006. When a group of us at the University of Cambridge took a look around, a bunch of us who were involved in undergraduate admissions. We were involved in, I had a role called Director of Studies at my college, and I was responsible, Directors of Studies try to organise undergraduate teaching, but they also try to organise the student undergraduates. So you go out and you talk at schools, you interview the people who come in, these incredibly nervous 17-year-olds who come and knock on your door in December. It was always really struck me when you open the door, you'll interview somebody for half an hour, and then you open the door, and there'll be a young boy or girl sitting on the chair outside, and they jump. They always jump. You open the door, they jump, they think, is it me? And then you have to say, give me a moment, I need to write up my notes from the previous interview, and then you open the door again 5 minutes later and they jump again. And interviewing sixth formers to come and study computer science at the University of Cambridge, which is probably, it's the best place in the UK to study computer science, it's one of the best places in the world to study computer science. It's a fantastic experience. These are amazingly bright kids. But what struck us, those of us who were involved in this in the sort of 2006 era, was they were still fantastic kids, but we just weren't seeing very many of them anymore. That we'd grown very used. When I went to Cambridge in the mid-90s, there was something like 7 or 8 applicants for every place. By the time I was interviewing people a decade later, we only had 2 or 3 applicants for each place. And so we started to look around and ask ourselves, what had gone wrong? We wanted to we wanted to understand how we'd gone from a world where we were besieged with applicants to a world where we still had a good number of applicants and we still had a good number of good applicants. But it was starting to look like a trend that if it continued for any longer was really going to damage our ability to continue to teach computer science at the university. And what we settled on a hypothesis, we're mostly scientists, we settled on a hypothesis, and our hypothesis was that we had a lot of applicants because people had been programming in their homes. Children have been able to program in their homes. Computer science and engineering more broadly are difficult subjects to recruit for at university precisely because we don't teach anything at school, which most schools don't teach anything which really feels like engineering. It doesn't take, if you're good at physics at school, it doesn't take a lot of imagination to go, I'm good at this and I enjoy this, I'm going to go do more of this. It actually takes quite a lot of imagination if you're not studying computer science, if you're not studying engineering. It takes quite a lot of imagination in a 16, 17, 18-year-old to think, I'm going to go and devote 3 years of my life, and particularly these days, tens of thousands of pounds of money, to this thing that I know nothing about, to this thing that I only have the vaguest idea of. Now, home computer hacking had filled, and we hadn't realised this was happening at the time, I think. Home computer hacking, the sorts of things we see at the back here, had filled that niche for a lot of young people. It provided young people with an early experience of engineering. It had become very important to the engineering recruitment pipeline at universities. It had become very important to the computer science recruitment pipeline at universities. So, unfortunately, those machines went away. The machines that I had when I was a kid, I had a BBC Micro. A lot of people in this room will have BBC Micros, Sinclair Spectrums, Commodore 64s. Probably quite a few of us in this room have one of each. I came in through the BBC Micro. Those machines went away, and they were replaced in large part, at least on the games side, which is what drew a lot of people, what got a lot of computers into a lot of young people's lives, were replaced by fixed function devices. They were replaced by games consoles. Now the PC was still there. The PC is awesomely programmable, but the PC wasn't in it. It's still not the case that every family has a PC. There are still many, many households in the country that either don't have a PC or that only have one PC. They have the family PC. The funny thing with the family PC is that you can install Python on, and the family PC is probably virus-ridden, but it's perceived as a piece of family infrastructure. It's perceived as a thing that you shouldn't screw around with. You wouldn't let your kid take your car apart. Why wouldn't you let your kid take your car apart? Well, maybe you would. I mean, it's a room full of engineers, but I wouldn't let my child. Why take my car apart? There's two things. It's a complicated piece of equipment. They'll probably make a mess of it. And two, if they take it apart and company back together again, your family is out a piece of family infrastructure. It's going to cause significant inconvenience to your family. And the family PC is a lot like this. You might let your child take their bicycle apart because a bicycle is a simple piece of equipment. And if they destroy the bicycle, the worst that's going to happen is they're going to have to walk a little bit more, or beg you for a lift. Really, Raspberry Pi is that kind of bicycle. The bicycle analogy has come up before, right? I mean, the bicycle analogy was one of the very earliest sort of thoughts around the Macintosh was perceived as being a bicycle. We perceive the Raspberry Pi as being a bicycle because it is a breakable piece of hardware. It is a low consequence environment for young people to have their first experience in computer science and engineering. So 2006 we had the idea, 2008 we started the foundation. We thought we had a product, we thought we had something which was inching towards being a product. We called it Raspberry Pi famously because Raspberry is fruit in computer companies, and also the rudest fruit, seriously, the rudest fruit, that was and then Pi because of Python. We're big fans of Python as a teaching language. The earliest prototypes of Raspberry Pi, we were such big fans of Python that all they could do was run Python. They booted into Python in the same way that those machines that we have in the 1980s booted into most. So 2008 we incorporated the foundation. 2011 we accidentally told people what we were going to do. We had I went to talk to Rory Kessel-Jones at the BBC and told him what we were planning. He put it on his blog, and he had 600,000 YouTube views in 2 days of this. Just a video just holding up a very, very early prototype that looks almost nothing like the Raspberry Pi you see today. In fact, to the extent it's such a massively popular blog post that his next blog post was an anatomy of a viral video post where he's trying to understand what it was that had made that post viral when other posts were going viral. So 2011 that happened, and then towards the end of 2011, as an organisation, Raspberry Pi is a charity. We can't raise risk capital. That's the big challenge. And what's the wonderful thing about being a charity is that everyone can be certain that the money that is being made out of Raspberry Pi is going to a good cause. No money is leaking out. When money comes to Raspberry Pi for a Raspberry Pi, one of two things happens to it. It either gets used for engineering, it either gets used to make a new, better Raspberry Pi, or it gets returned to our parent organisation, which is the charitable foundation, which can spend on good works. And a lot of people, I think, are drawn to the Pi because they know that none of the money there is leaking out into the pockets of some Raspberry Pi shareholder. So there are advantages to being a charity, but there are disadvantages to it. The primary one for an organisation that's trying to scale is even once we got to the point where we knew we could build a Raspberry Pi, we knew we could make it profit, we knew it was technically feasible, and we knew it was economically feasible, there was no way for us as an organisation to raise risk capital, and there was going to be a limit on the scale that we could take what we knew was a very good product. And so we were very pleased that we were visiting. Wave, it's your fault. Stand up here, this is your annual taking away. In December of 2011, I got an email from Pete Willard back there, who had written a blog post on the Design Spark blog. He said, we had a lot of social media interest after this YouTube video, a lot of social media interest in Raspberry Pi, and Pete had written about how exciting he thought this was. And I replied to say, that's great, would you like to make the Raspberry Pi? Which was probably the ballsiest email I've ever sent, and also probably the most productive email, the email with the highest end result. We got talking to Pete, we got talking to Glenn, and by the middle of February 2012, we had agreed to change what Raspberry Pi did from being a capital-constrained hardware manufacturing organisation to being a licensing organisation. We designed the Raspberry Pi, we maintain the Raspberry Pi brand, and then we leave the manufacturing, the manufacturing, the supply chain management, and the customer interaction to RS, who, let's face it, much bigger and better at this than we can. We launched on the 29th of February, which was an unusual choice, kind of screwed up our first, second, and third birthday parties, but we're going to have a really good time tonight. And we sold about 100,000 units on the first day, 1 million units in the first year. Today, along with the Raspberry Pi 3, we're announcing that we've sold 8 million Raspberry Pis, which is fantastic because it takes us past the Amstrad PCW the unlikely holder of the title of the previous holder of the title of most successful British microcomputer. When we sold 5 million Raspberry Pis, we went past the Sinclair Spectrum, and we put out a rather pleased with ourselves tweet to that effect, and the PCW community then appeared. I didn't know there was a PCW community, but there is. They appeared, and they told us how very, very wrong we were. So we are now past all sugar, so that's a good place to be. So yeah, 8 million of these things in the wild. Probably roughly 4 million of them have gone into the maker hobbyist community, the adult technically illiterate community, people who already, and that was really probably the heart of Raspberry Pi's early success, was that there were people who already had ideas and things they wanted to do. They had latent projects in their minds they wanted to do, and there was no tool they could use to do it. So about half of them have gone to that community, about a quarter of them maybe have gone into the industrial and embedded space. Raspberry Pi turns out to be an amazing piece of hardware for doing industrial embedded control. We didn't see that coming. It's, I think, a testament to the power of what happens if you, there have obviously been single board computers for industrial control for a long time, but there's a testament to the value of volume. If you are put 8 million units of something out, the bugs really do get, many eyes do make bugs very shallow. The bugs get ground out. And it's really found a home in a lot of very surprising industrial contexts. A couple of million have gone into education. That's massively beyond what we were expecting. We're seeing great, we believe that great progress is being made there. That one raw number of applicants at the University of Cambridge to study computer science is now above where it was in the dot-com boom, so it's on previous high. And to be honest, in the dot-com boom, we had 600 applicants to study computer science. We didn't want a lot of those people, because a lot of those people were people who thought computing was a meal ticket. There were people who read about dot-com, big dot-com exits. There were people who weren't interested in it for the right reasons. They didn't want to do it because it was a meal ticket. So we actually think, we have 700 or 800 people apply. We actually think the quality, the caliber, and the level of commitment of those people, the level of experience they have when they come in the door, is probably better than you've ever seen. And that's a story that's replicated across much of the British higher education sector. As we've been doing Raspberry Pi, there have been some wonderful advances in parallel. We kind of feel like we're part of a broad front of people moving forward together. We've had, obviously, fantastic curriculum reform. We've had some great post-Eric Schmidt's Taggart lecture in 2012. We've seen a great commitment from the government in terms of revising the curriculum to be more rigorous. It'd be great if they would match that with the commitment to teacher training on an appropriate scale, but it's better than nothing. And we've seen a lot of voluntary organisations really step up, a lot of voluntary organisations and corporates step up to fill that space. So yeah, it's the 29th of February 2016. We thought it'd be fun to celebrate with a new toy. That was all that we were thinking. So Raspberry Pi 3 launches today, available immediately from RS Commerce. You got any left?
Yes.
You got some left? Good.
Yes.
Excellent. Fantastic. We have built an awful lot of them this year. I mean, this year we have built more before launch day than we've ever built of any previous Raspberry Pi product. It's available today. Half again as fast as Raspberry Pi 2, which is in the market for 13 months. About 10 times as fast as the Raspberry Pi 1. It's got 4 times the memory that the original Raspberry Pi had, so it has a gig of RAM versus 256 in that product we launched 4 years ago. And we've been able to integrate connectivity. And I think that connectivity, where the other things are quantitative changes, really the connectivity, the integration of connectivity. I was just talking to the PyTop chaps at the back. It's a step change, right? I mean, it lets you do things with the Raspberry Pi. You could always do these things by plugging Wi-Fi and Bluetooth dongles in, but there's real value to having that integrated into the platform. And we've been able to squeeze it to the original price point. We've been able to squeeze it to the $35. So yeah, we're it can be difficult being so close to Raspberry Pi. You know, you play with the hardware every day. You know, you've got a fantastic engineering team. We've recruited an amazing engineering team at Raspberry Pi. I basically work my Rolodex, and I'm old, and I've found the brightest guys that I've ever met, and I've been able to persuade many of them to come work for us at Raspberry Pi. You spend a lot of time hanging out with these guys who are intimidatingly smart, working the issues, around getting a product like Raspberry Pi 3 out the door, and it's easy to not play with it until the last minute. It's really only the last week that I started to sit down with Raspberry Pi 3 and actually use it as a machine. And it's, I've got to say this because it's my product, but it's an amazing piece of kit. I mean, it's, for me, if there's one thing we've done, we've crossed that line, really credibly crossed that line from being a toy into being a PC. And that's really important to us. It's important that this is a valuable platform for kids. It's important that this is a platform that kids want to have in their lives because they can go on the web and they surf the web on it and they can play Minecraft on it and they can watch videos on it. It's important that it has that functionality. It's not supposed to just be a worthy platform for learning. It's supposed to get into children's lives because it's useful for them as a general purpose piece of kit, and then beguile them into programming in the same way that I was beguiled. I was beguiled into programming as a 10-year-old typing 10 print I'm the best 20 go to 10. You know, or 10 print something much ruder than that, 20 go to 10, go to Dixon's and type it into all the machines. Looking through the window as the guys are frantically pulling power cables out. So it was we made our own entertainment in the 1980s. I owe everything that I had in my life to the hardware I had when I was a kid. And I hope that there'll be kids who look back on the Raspberry Pi, and particularly the Raspberry Pi 3, with the same sort of affection I look back on the hardware as a micro. So we've enjoyed making it. We've absolutely enjoyed working with RS on getting it into your hands, and we hope you enjoy it as much as we do. So thank you very much.
Thank you, Evan. I think today is the morning after the Oscars in the U.S., and I don't know if anybody watched it here, hopefully not, because it would have been on at 1 in the morning, but they were shortening the speeches to 45 seconds, and then the music would cut on. And I just realized after 20 minutes, the music cut on for you. So,
it sounded like a fax machine. I don't know what it was.
I don't know. It's probably in your head. I don't know. Those are orders coming into RS. So it's a pleasure to be here today. We're very excited about the Raspberry Pi 3 launch. As Eben said, we started 4 years ago. Thank you, Pete. He blames you. I thank you. So Pete works for RS, of course. So we started this partnership 4 years ago. As Eben pointed out, this is actually the first anniversary because it was a leap year then, as it is today. And I hope 4 years from now we can stand up and instead of selling 8 million units, we can say we've sold 80 million units because of the adoption of the B2B community. So the great thing about Raspberry Pi is I've gotten into this and started looking at it's made it easy for students and for younger people, as well as adults, to be able to design things. And it's also at a price tag that's affordable. So those two things are really, really important. A passionate user community. Obviously, there's no shortage of passion in Eben, but a very passionate user community, which is a community. As I was talking to someone this morning, you got to be careful not to commercialize the community because it then becomes a network and people won't want to be involved. So there's a very strong Design Spark community around Raspberry Pi, which we're very excited about. We've got product on the shelf, so come to us. We've got product. We've had a lot of sales already today, so very exciting. What we're going to do now, actually, we're going to walk around. I'm going to come back and say a few things here at the end, but we're going to walk around. We're going to take Periscope with us. So come on, and we're going to show you some of the displays that we have here today and some of the products that are using Raspberry Pi. So we're going to start here with Matt, and this is Pete.
Morning. So Matt, your 15 seconds of fame. Tell us about yourself.
So my name is Matthew Thomas Brown. I'm 16 and I run a Raspberry Pi YouTube channel called the Raspberry Pi Guy, and today I bought a robot which I've made completely from scratch based around the Raspberry Pi.
Very cool. Okay, moving on to Alex Ames.
Hello, I'm Alex Eames from Raspberry Pi TV. I expect a few people will laugh hearing that because that's how I start with my videos. I have a blog and a YouTube channel, and I've brought some demos here today. I've got a nice Wii controller robot which is running off a A+, which is rather fun. If anybody wants to have a go with that, come and grab me afterwards. I've also got a little Raspberry Pi based camcorder here, which can be used to film things and take photographs. I also have a few products and things of my own. This is a recent board that I launched on Kickstarter, which finished a couple of weeks ago and did quite well. So,
cool. Thank you, Alex. Great stuff. Moving on to the PyTop guys. This is Jesse.
Hey, I'm Jesse. I'm one of the co-founders of PyTop. This is John, part of the PyTop team. We make Raspberry Pi-based laptops and desktops. So you can just pop your new Raspberry Pi 3 in here. It's got 12 hours of battery life, a 13.3-inch HD screen, and yeah, the cool thing about these is when a new Pi comes out, you just take the old one out, put the new one in, and it works.
Great stuff. And we're going to be selling these very soon at RS as well,
Yeah.
which is great. So, okay, moving on to Alex Gibson. Alex, show us your Pi-Power 3D printer.
Hi there, so I'm Alex Gibson. I'm a 3D printing and maker technologies consultant, and I've designed a totally parametric 3D printer that you can really build around any specific 3D printing application. And here I'm trying to make it much more reliable and trivially easy to get files onto by using a Raspberry Pi 3 and Octoprint to make it web enabled.
Great stuff. Thank you, Alex. Moving on to Michael. Michael's also a maker. Has some great projects here today. Michael, show us what you've got.
This one I'm particularly proud of. It's called the Picorder. It's a box full of sensors, gas sensors, GPS, barometer, and just various LEDs just to make it look pretty.
Fantastic. Thank you, Michael. Moving on to Dave Akerman here. Dave helped us put Superman into space a couple of years back. Dave, tell us about your projects.
I'm one of those engineers that was brought up on BBC Micro and had a latent requirement for the Pi when it came out. So since it came out, I've been slinging them up into near space, into the stratosphere. And on the table here, we've got 3 of the Pi-powered space travellers that I've sent up. We've got TARDIS, which one of the first ones, Babbage Bear, which that's the original Babbage that jumped from 31 metres above Felix Baumgartner's record.
Fantastic.
Beaten by that Google guy, so have another go sometime.
Very good. Thank you, Dave. We'll just wander down the other end here. Okay, start with Andy Stanford-Clark.
Hi, I'm Andy Stanford-Clark, distinguished engineer for IBM, the Internet of Things. We've been using Raspberry Pis to integrate IoT applications, particularly linking them with Node-RED, the application that IBM developed for easy programming for Internet of Things applications. This is the Isle of Wight ferries going backwards and forwards between the Isle of Wight and Southampton. You can see the red jets here. I live on the Isle of Wight, so this is particularly handy for me commuting. This is showing how much power my house is using, green at the moment, so that's good. And I also have the world's first hydrogen-powered Raspberry Pi 3, powered from a hydrogen fuel cell, and this will be integrating data from the Internet of Things up to the IBM Watson IoT platform.
Fantastic. Thank you, Andy. And moving on to Stuart here. Stuart has a Raspberry Pi selfie camera.
So I'm a Design Spark blogger, and today we brought along a demo unit that's doing face detection, and it automatically takes a picture of you and then sends it over to another Pi, so we can do some demos a bit later on with that.
Fantastic. And moving on to Lucy, I guess now.
Well, go ahead and do you want to show your demo?
Okay, here I've got a dinosaur that you can tweet with the hashtag WakeDino and he nods, a light that lights up when the International Space Station goes over, and a bigger dinosaur, but I'll be talking about those later.
Fantastic. Okay.
Okay, thank you, Pete.
Okay.
So thank you to our guests here today, to the exhibitors. We did check with Matt to make sure he's 16, that he's out of school legally today. So he's got an official excuse. We're going to have to change his name though, so nobody tries to hire him. So I guess that's live. So we won't say his last name. You know, what's really exciting, I think, about the Raspberry Pi 3 is the integrated Bluetooth capability, wireless LAN capability, the Node-RED. These are capabilities within Raspberry Pi 3, which, as Eben pointed out, make it much more appealing for the embedded industrial market. So I think from an IoT perspective, moving forward, we're going to see a lot more activity in B2B, where historically we've seen a lot of B2C activity. So we're very, very excited about that. We're highly committed to Raspberry. When you think Pi, we want you to think RS and not 3.14, but think RS, and that's what we're all about. I think what's really important with Pi is the STEM skills within the UK and the western part of the world are not what they used to be. So science, technology, engineering, and math. And Raspberry Pi helps to bring some of the skill set back to the western part of the world. If you think about it, the first 1,500 years of business, the center of the universe was between India and China. And since it's kind of shifted to the Western world, but there's a sense that it's moving back. And we've seen a lot of activity recently in the semiconductor world of China becoming a much larger player and attempting to acquire Western companies. So I think it's very important for us with Raspberry Pi that we get it out to universities, we get it out to engineering students, and we help support and drive the maker movement. So there'll be some things we'll announce later this year from RS to help drive innovation within schools and universities. Very important for us. So at this point, I'd like to turn over to Dr. Lucy Rogers, who's a maker, who's a scientist, who's a Raspberry Pi enthusiast. Dr. Rogers?
Computing and electronics is black magic. Or at least that's what I used to think. I wanted to make all these things, but sparks would come out, the blue smoke would be lost, and everything would not work. So I stuck with mechanical engineering. I'm a mechanical engineer. I like cogs and things that move. And I'm also a maker. I like doing practical stuff. I make things. But talking with my friends in the maker community, I realised that there was this Raspberry Pi thing. And with a lot of mentoring and help from friends in the maker community, as well as Andy Stanford Clark, who was demonstrating some of his stuff here, took me step by step through using a program called Node-RED, which is a visual flow programming language. I can just drag and drop the bits that I need to code, and I didn't have to worry about where I put my semicolon or my parentheses. Doing this, I made my first little thing. I managed to get a Raspberry Pi to tweet me when the International Space Station was going over. I thought, this is great, but what if if I'm not looking at Twitter? I still want to go out and have a look at the space station and go across and do my wave to the astronauts, but I really want a light that shines, so that if I'm sitting there doing something else, at the corner of my eye I see a light shining. I know when to go outside. So this was my first experience of actually connecting things. So I'd taken my first step into software, and now I was taking my first step into electronics. Again, with a lot of hand-holding and mentoring, I got the GPIO pins, the general purpose input-output pins, on the Raspberry Pi, connected to some LEDs, and I've got now a little tile that lights up 30 minutes before the International Space Station goes up. It gives me a couple of flashes. 10 minutes before, it flashes again, and 5 minutes before, it's on constant, and all the time the International Space Station goes over, it's on constant. So that was my first steps into Raspberry Pi computing and electronics. From that, I got hold of a child's kit electronic dinosaur, little robot dinosaur. And with a bit of fun, I hacked it so that now when you tweet #WakeDino, it starts nodding. I was just wondering if anyone was going to. There we go, thank you. It starts nodding. This is a kit that children can use, so it's not just the makers like me who can now do those little steps between doing the computing, doing the electronics, putting them together. You know, the children can do it as well with that sort of thing. But this led to me being invited to Black Gang Chine on the Isle of Wight that have rather large animatronic dinosaurs. They have a 16-metre T-Rex. It's huge. But there was a problem with some of the electronics. It had gone wrong, and they phoned the suppliers, but the suppliers were in China. I said, oh yeah, we can send you some more bits, but it'll take you 6 weeks to ship it over. Blackgang Chine, like all tourist industries, have a really busy summer 6. And if you haven't got a display working at the start of that summer 6, and you're going to take 6 weeks to get it fixed, there's going to be a problem. So I got invited down, and I called on my maker friends. Who wants to come and hack some robot dinosaurs? There's cake as well. Coding for cake. It worked very well. And so all the maker people came down, fixed the electronics, made some actual more electronic boards, realised that the control boards could be a Raspberry Pi. So now we have Raspberry Pis and some control boards in the dinosaurs on the Isle of Wight. We also trained the staff there, who may be in their normal roles, the fiberglasser, the painter, the gardener. We trained them, as well as their tech people, how to program using Node-RED, so that if the dinosaur goes raw and then opens its mouth, they can actually program it so that it goes raw and looks a little bit more realistic. So using Node-RED, Raspberry Pis, we've managed to hack these dinosaurs, and the small one that I've got over here that's nodding away is effectively a replica, and so I can take that small one now back into schools, get children to program it, take the card out, put the card in the dinosaurs at the theme park, and the children have now programmed those dinosaurs and they can use those. So electronics and computing, black magic. With a Raspberry Pi, it can make things magical.
All right, I think at this point we're going to open it up for Q&A. So, any questions? Eben, you want to come up?
I've got one question that's sort of societal and one more technical. Eben, you said the number of applicants have gone up since the project has started. I mean, how much of that can you attribute to something like this, you know, amongst other efforts? And have you seen a change in the gender balance as well amongst those applicants?
I think we can attribute all of the credit to the team, to the group of organisations that have been doing stuff in this area, and that's Raspberry Pi, Code Club, who we've actually now merged with, Coder Dojo, various industry initiatives. So I think that there's kind of, like I say, it's felt like being like part of a broad front, kind of moving forward together. So I think 100% of the credit can be attributed to that. I think it's futile to try and attribute credit inside that. In terms of gender balance, we've seen a little improvement. There's still an enormously long way to go. A lot of our focus, particularly through our work with Code Club, who is a nationwide, well now worldwide network of after-school programming clubs for 19-year-olds, is to reach girls before they realise that STEM subjects aren't for them. There's a misconception that occurs at some point around about the age of 11, where girls are often doing better than boys, and yet somehow they become convinced that they should stop doing STEM subjects. And so there's a real effort. There's evidence that if you can get people over that little road bump, there's a little speed bump there at about 11. If you can get them over that speed bump and they're still interested by the time they get to 12 or 13, then they're going to keep going, and they're going to keep going often outperforming boys. So there's a need for targeted intervention. I think the reason why we haven't seen a meaningful change in the gender balance at the university application point is because we've only been doing this for 4 years. So the 18-year-olds were 14 then, and that's probably a little too late to make a difference. Hopefully, if we don't see something in another 4 years, I'm going to, particularly because we are focusing very, very hard on this, if we don't see something in another 4 years, I'm going to be this.
And on the technical side, you've obviously gone with the 64-bit A53 with this, but I think there's a little bit of confusion over the OS and these things because you don't get sort of full performance on the V8 instruction. You just sort of clarify how that works.
So we have a 64-bit processor, which we do think opens up new opportunities, particularly in terms of the kinds of operating systems. So we can hoping to lure Red Hat onto our platforms. They're obviously die-hard 64-bit fanatics. The main reason we chose the A53 though is that it's a better 32-bit processor. You know, the A53 is the spiritual successor to the A7 that we use in Raspberry Pi 2. It is in every way a better 32-bit processor. We'll be running it in 32-bit mode for at least the first 6 months. I think we're going to wait for somebody else to demonstrate to us that there is a benefit to running 64-bit. There would be a substantial cost to us in maintaining, because we still have we have 8 million products in the field which are not 64-bit. There will be a substantial cost to us. We couldn't orphan those, so we need to support both the 32 and the 64-bit world, and we really want to convince ourselves there's a benefit to 64 before we take that further.
Yeah, actually, in the 32-bit mode, do you get access to like all the additional neon instructions that came with V8, or do you have to move it to 64-bit?
You get some of the additional, so ARCH 32, which is the 32-bit mode on an ARM core, does have access to some of the additional neon instructions. There are some floating point rounding instructions. I think some. Yeah, there's a fairly small bag of neon instructions that you get. I'm not sure how useful those are going to be for particular use cases, but you do get access to them. Whether we will enable them is another. Whether we will start to make the compiler aware of them, whether we'll start to turn on and assemble fast files and use those instructions. I suspect, given the general state of assembler fast files in ARM world, there probably aren't any fast files that use them. So we'll keep an eye on it. It's the 64-bit side and the ARCH 32 side are more future-proofing thing for us today than they are a feature version.
Other questions? John?
What advice would you give for sort of maybe tired, slightly disillusioned teachers who they can see it, but their management team's not behind them? What do they do? Do they start a club? Because I've met some of these teachers.
By the way, so John, you're familiar with FIRST in the US, right? So the FIRST robotics competition, which now I think has over 30,000 students participating. It's things like that have, I think, reinvigorated STEM in the US, in particular in high schools, because that's targeted for really kindergarten through high school, which has made a huge difference.
I think there's a lot we can learn from the American experience. So, we're basically very near Lincoln Air Force Base. I've been up there a couple of times to talk about high school. They've got 2,500 kids on this base, right? They've got 2 primary schools and a high school. I've been up there to talk to their high school shop class, and it's amazing how they're very passionate believers in the first thing. I think there's a lot of that kind of practical-based stuff, which is both possible for teachers to deliver. There are pre-packaged. Increasingly, there are from a lot of sources. First in the US, from obviously Code Club in the UK. There are a lot of sources of pre-packaged, pre-verified. Teachers are professionals. I come from a teaching family. Teachers are professionals. They want to do a professional job. They want to deliver a good experience to the kids. One of the challenges, as I alluded to in my talk, is that the government's really laudable changes to the curriculum have been backed up with about £2 million of teacher training funding, when it's basically a £100 million challenge. And it's very, very hard to ask teachers to step into that, you ask them to step off a cliff with no support. These are people who've been used to delivering the ICT curriculum. They're now being asked to deliver what's really a very robust academic computer science curriculum with virtually no support. So I think it's those pre-packaged sets of resources. The after-school club thing is very valuable because it gives you an opportunity to deliver this stuff in in an environment without the spectre of assessment hanging over you. I think, I was never taught computing at school. I think I had an afternoon of logo in a maths class when I was 15. I was never taught computing at school. All of my best experiences with computing were informal experiences either at home or in an after-school context. So I think probably what advice? Don't despair. We know that everyone knows that there's a problem here, and there's a lot of people trying to fix it. We have a thing called PyAcademy. It's not at scale yet. We've put about 300 teachers through it. So far, we actually, just this weekend, PyAcademy in North America, something like that. There are 100 initiatives like that. You're just going to go and find them.
A couple of tiny roadmap from here.
Yeah.
Any clues to rough?
80 million.
Yeah, 80 million. Yeah. So it's that curve just going to keep going up. Obviously, in terms of numbers, I want 12 million really badly because that gets us past the C64 into third. The remarkable thing is we get us into third place, right? Behind the Mac and the PC, who are kind of basically on the same level. I wouldn't, one I think very important thing to say, I wouldn't want to give the impression, we've put 2 successive product generations out in very quick succession, Pi 2 and Pi 3, 13 months apart. I wouldn't want to give people the impression that they should rely on there being an annual cadence. From here on out, I think Pi 3 has got us to a very nice place. I think you're probably going to see, Pi 1 was in the market for 3 years. I think during that time we put a lot of effort into software work that gave a continuous improvement on a fixed hardware platform. I think you're likely to see us probably swing a little way back towards that sort of model for the next couple of years.
And just quickly, finally, you described it as breakable for the kids.
Yeah.
Is there a memorial website for pies that died?
There should be. My favourite one of these, we've always been very, was taking a very serious approach to product safety on the Raspberry Pi. This is live. It's a laugh. I've got James at the back besides it. We've always taken a very serious approach to product safety. There are some things you can't hedge against. The one that I would put at the top of the memorial page in probably our first 2 or 3 months, we have somebody who took a Raspberry Pi and powered it. We don't recommend people power Raspberry Pis from PC USB because they don't provide enough power. But powered it from one PC, plugged it into a monitor that was attached to another PC, and both PCs had uninterrupted power supplies, and therefore they had vastly different ground levels. And he was able to push something like 40 amps ground. Black. We don't make black Raspberry Pi, he made a black. So that for me, there ought to be a memorial website for me. That would be the one that would go. It's right at the top. Do not do that.
Yeah, I think too, on that note, John, there's still demand for Pi 2. And we still have Pi 2 on the shelf, so we still have that in stock, and there will be demand. I think at the same time, when you look at roadmap, what I find quite interesting about Pi is every day people are finding new applications. So it's just now, in my opinion, even though 8 million units is sold, it's still in its infancy. And now that it's moving over to the industrial market, more and more engineers are starting to use it. One of the things that we'll be announcing later on this year is kind of a traveling experience to where we take products to schools and to companies and part of a technological roadshow. So more to come on that later on. But I think what's important is for people to understand the applications and what they can use it for, because not that many people, there are a lot of people that are aware, but there's still a lot more people that could be made aware of.
People need to, I think, I would love it if in the industrial space, people understood that, it's cheap, but it's low, it's inexpensive. There we are. So this is why I knew I was going to get it wrong. So Liz will be watching this. It is low cost, but it's not cheap. It's a platform that, by dint of its massive sales, has been polished to a point where it's very well understood platform. It doesn't have the bugs that people have in a product that's selling tens of millions. It's a more nominally more specialist product that's selling tens of thousands of units a year. It just has that polish. It's great whenever we see it. I look behind when I'm out and about now. I look behind displays. When I see a digital signage display, I look behind. Increasingly, I see Raspberry Pis. And you go into, in fact, you bump into somebody. I bumped into a guy at one of the big shipping companies, one of the big parcel shipping companies the other day. And he was saying, we just use this in production everywhere. All our depots have them, we just use it for everything. And I think that's probably going to be a big part of the Raspberry Pi, aside from the education angle. That's going to be a big part of the Raspberry Pi story in the next bit.
Now that's cool, Mike. Wherever Mike is. Any other questions?
Yes.
I'm Trevor, IT Pro. There's been something of a boom in retro computing recently, with notably both the ZX Spectrum and the BBC Micro receiving newer, updated versions, quite often crowdfunded. Do you feel that the Raspberry Pi has been responsible for this resurgence?
I wouldn't say responsible, but I think what we've done is we've demonstrated that this sort of thing is feasible with that if you have a small team of bright people, you can do surprising stuff. You know, if you've got that combination of bright people and a good business model. And of course, crowdfunding gives people access to I mentioned in my talk, access to capital being like a real constraint for people now. Obviously, we took one approach to this. It's worked very well for us. We never use crowdfunding. We never will use crowdfunding. But for people who aren't lucky enough to get a mail from Pete, crowdfunding can be a way of these things, and it can be a way to unlock the abilities of a wide team. I'm looking forward to getting my hands on a little Vega Plus. That's looking good. That's looking good. You know, can try and beat my old-time Manic Miner. And it's great to see this whole retro thing. I like it, and it's interesting that kids actually quite like the retro thing. We do a lot of work with the Community History Museum in Cambridge, and they get kids in and they put them in front of old machines. They have a lab which consists 50% Raspberry Pi, 50% BBC Micros, and the kids love them both. You know, they really do. There was always, I said, this Raspberry Pi is a hypothesis, right? The Raspberry Pi is a hypothesis test, and there was always the null hypothesis is kids don't care. The null hypothesis is kids want to get on Facebook, and it turns out not to be true, actually, and particularly the physical computing angle, which is something people always used to be able to do with BBC Micro. You have the user port, the printer port, waggle little pins. Not the same with the Raspberry Pi. Physical computing actually is for a lot of kids the way these days. Moving a pixel around on the screen, which I used to be doing, it's less cool than it used to be. Moving an object around like a little remote thing, moving up an object around the real world is just as cool as ever was.
Any other questions? Andy.
Andy Stanford Clark from IBM. On the subject of Internet of Things, people keep asking me, putting things inside of plants and things. What's the future hold for Pi Zero?
The Pi Zero is obviously the product that we launched in November. It seems pretty popular. It's a nice, popular little piece of kit. Still selling extremely well, selling as fast as we can make them. I think like all Raspberry Pi products, I kind of have this dream nightmare that one day we'll release a product that will have made enough and then no one will buy it. And so I kind of probably rather, we have to be cautious with Raspberry Pi. We don't want to be cautious with Raspberry Pi products. We don't want to lean too far forward. And I'd rather it was that way than the other way around. So maybe with Pi 3 we're going to hit it on the nail, because I think what we've got is a decent amount of supply on the first day, and then we've got good pipeline. So if we have better pipeline. Last year, Pi 2 had a good number on launch day, and we had a reasonable pipeline for the first month or two, and then it was so much demand that we sucked that pipeline in and then kind of fell over a little bit in May. This time what we have is a very well-structured pipeline all the way out to the summer, so I'm really hopeful we won't see either shortage or that kind of period of sufficiency followed by a crash that can happen if you don't get it right. It's a lot of effort, massive amount of remaining the team. Staggering amount of effort in this right now.
So if someone ordered 100,000 Pi Zero, the answer would be no.
The answer would be no to that, yeah. because you'd be starving 100,000 individuals
Is there a critical path on the bill of materials?
Critical path for bill of materials for Pi 3. Yes, there will be. It's never what you think it is. It tends to be little stuff actually. No, then I experience this a little bit. It's because you've got you look at a Pi 3, you've got basically 4 bits of non-trivial, non-trivial. Also, it's not trivial. 4 bits of non-trivial stuff. You've got a DRAM, you've got USB, Ethernet rich microchip, you've got the 2837, and you've got the Wi-Fi chip. Those are the non-trivial bits. So an enormous amount of effort and energy and attention goes into establishing the pipeline for that. But what you have also, you've got 200 other components. And so actually your risk, so the way I always think about it, I always focus on the big ones, But actually the risk, if you have 199 of those 200 components, you can't build. And so you're actually, the risk, although the individual risk for each of those components is low, it's simply the fact that they're all risk. Just, collectively it just winds up. So we think we've got it under control, but things always come in your out left field, and you've got to have a plan for it.
But as you know, I think we're in a relatively soft electronics market today. So semiconductor lead times are relatively low in comparison to where they have been.
I would presume that as you're offering or putting out there a totally sorted, nice, easily panelized board for assembly, the CDMs will bite your hand off.
Yeah, so we build 100% of Raspberry Pis with RS are built at Sony Bridge End, the Sony UK Technology Centre in Pencoed in South Wales. We're incredibly proud to be building. I mean, just to your point earlier about the kind of the movement of the centre of gravity of the electronics industry and the economy in general, backwards and forwards in different places. We are enormously proud that we're building it in Wales. We're enormously proud that we're building it in Wales for economic reasons. We're building it in Wales because I say this in front of every audience I stand up in front of. We are not building it in Wales because we're nice people. We are building it in Wales because they are best in the world at making this. They are the most cost effective in the world. They are the highest. They are amazing people. If we ought to organise a trip sometime and invite as many of you along as we can, because it's just, you wouldn't see just the level of automation, particular level of automation and test, and that's the when we talk about manufacturing resurgence, and there is a manufacturing resurgence in this country. The downside is it's largely automation driven, and therefore manufacturing is never going to be the mass employer that it used to be. But the good thing is the jobs it's creating are higher value jobs. It's creating equipment, effectively testing, rather than creating jobs with people testing things, it's creating test equipment design jobs, right? And that's incredibly valuable. So we're into our 4th year now of working with Sony. We still love them. We should get some of you guys out there. It's a real thing. We should do. It's amazing. You love it.
Well, one thing I really appreciate about the Pi is that at its price point, it's incredibly reliable and well tested. Now that you've got past the release of the Pi 3, are there any plans, or does it already exist, to put out in a structured manner how the team achieved what it achieved? How other people could reproduce your success in other fields?
That's a very interesting question. That's an interesting idea. I mean, there is a lot of. I think we've learned a lot doing it. I mean, James, we've learned a lot doing it, right? Yeah. I mean, I think probably from what we were talking about the other week, if there's one thing that I would call out, just off the top of my head, and maybe we should try and write some of this down at some point. If there's one thing I would call out, it is the value of incremental engineering. That it's for me as an engineer, it's incredibly tempting. I like shiny engineers like magpies, they like shiny stuff, and I like shiny stuff, and I love building entirely new systems that are brand new and everything's perfect. And this time we won't screw it up, and you always screw up when you do engineering. And there's what we've done with the Pi, and we've done this at the board level, and we've also done this at the silicon level, because we've had some fantastic support from Broadcom on this, is to build four generations, because we had, in Raspberry Pi, when we had the kind of B generation of the Plus, so we've now built original Pi plus Pi, Pi 2 and Pi 3. We've built 4 generations of boards on 3 generations of silicon, and on the board level we've tried to advance incrementally and not disturb the architecture too much, and on the chip level, we've done likewise. We've taken basically the same bit of silicon, put better core, put better processing cores in it. You could, there's a kind of regression kind of curve thing, you know, you get this bug curve, and the reason why it's so reliable is we've written the bug curve all the way down. If we change too much, we jump up the bug curve again, and really that's I call it out because it pulls against everything that engineers want. You know, as you in the room who are practicing engineers, you want the shiny new stuff. It pulls against that, and that's been good for us.
There's a test-driven development. it would be fantastic if the team could, when you get a moment to pause, write something for the wannabe maker of the new product to show how to do that.
Yes, yeah, just.
You can do a video.
Yeah, that'd be
picture
great.
the inventor video.
Yeah.
You can ship it with every Pi 3. The language.
We should bottle that, yeah. But yeah. So that's one thing, and there's a million. That's probably the sandboxiest one.
Any final questions?
With all the extra pies that are happening now, the 0 at the bottom end and 3 at the top end, is the A plus on?
Was the A plus going to get squeezed? No, the A plus is still a recommended platform for people. Sorry?
For ballooning.
Oh, for ballooning. The A plus has a camera connector. So in general, what's the place of the A plus in the world that has Pi 3 and has 0 in it? Well, it's our recommended platform for industrial. Zero is not there for industrial at the moment. A plus is a very cost-effective, incredibly cost-effective platform by any stretch of the imagination, and it's our recommended platform for low-end industrial.
Okay, so we'd like to, we're going to do a toast here. So we've got, I think,
am I going to be able to drive?
Non-alcoholic toast. I think we have some raspberry bellinis, some raspberries, and maybe that's sparkling water.
That's good. It's just awesome. It's just doing all the art.
It's not alcoholic.
I should. I've got the
You can track it and put it on the
yeah. I think I'm down to those things.
Yeah. Oh, yeah.
This is the career I have.
Do you have one? Back?
Don't you have to have some food? It's okay as long as it's serve you a burger at the same
There is
time.
brunch in the back, so if you're aware.
Technically,
We do have food in the back. So everybody has, we're okay?
You get a note. I have to be off school today.
Ah.
I'm going to be off school tomorrow.
Now we got a cake to cut. Yeah, it's like a
I was going to say,
wedding.
is this legally binding?
Ready to
You get a
go?
lawyer to get out of this.
I don't know. I think it means this is exclusive.
Oh, yeah.
So we'd like to propose a toast to the launch of Raspberry Pi 3. To our first anniversary, 4 years later. So thank you to Eben, to the team, and we thank you all for being here today.
Cheers, guys. It's very pleasant. Yeah.
Oh, nice. Yeah, we got to cut the cake. A lot of raspberries there.
Sorry, I'm doing this.
So you guys have rumbled to the fact that
Stay still.
ingredient turns a raspberry Pi.
Do you want to jump?
Yeah, we're not going to have room for both of us.
No.
Right, come on. No, come on.
Okay.
So let's
All right, here we go.
3, 2, 1. Hurrah! There you are.
There we go.